Hello all and welcome to the Math 8 video for what we're calling rational equations. This video is just going to be basically the same as the one-step equation video. It's just you're going to be dealing with what we are going to consider rational numbers. Okay, so as you'll see when we look at some of the examples, because we're pretty much just going to go straight into examples because the steps to these equations are the same as any other one-step equation. Okay, so in this case, once again, make sure to know your inverse operations. So once again, if you have addition, the inverse operation to addition is subtraction. If you have subtraction, your inverse operation is addition, and then the same with multiplication and division. If you have multiplication, your inverse operation is division. If you have division, your inverse operation is multiplication. Okay, so all these depend on knowing how inverse operations work. Okay. Now, as I was saying just a second ago, before I got a little sidetracked there, is we're calling these rational equations because they deal with rational numbers, which all the other equations we have dealt with rational numbers because all of those numbers that we had could be turned into fractions. But when we talk about rational equations in this place, we're going to be talking specifically about decimals and fractions. Okay. So as we go into it, set 1 here. So if you look on the sheet, set 1 all has to do with decimals, and that's numbers 1 through 12 here. I'm going to go through these pretty quickly because, once again, the steps here work just the same as what we would do if these were just normal whole numbers or integers. Okay, same steps apply, meaning if we look at number 1, we have a minus 17.9 is equal to 32.4. Well, the thing that we want to do here is we notice the variables a. We're subtracting 17.9, so that means we need to add 17.9. But if we do something to the left side of the equation, that means we need to do the same thing to the right side of the equation. Once again, if you need to do this little trick where you draw the line so you know the different sides of the equation, that's perfectly fine. But our whole goal here is we want the 17.9s to go away. So we have a is equal to 32.4 plus 17.9. Once again, decimals make it a little bit harder to maybe do some of these calculations in your head, so I do strongly suggest knowing how to use the Desmos calculator here, and we'll be looking at the Desmos calculator here in a bit anyways when we talk about fractions, because I do want to make sure everybody's good with how to do fractions with the Desmos calculator. But in this case, 32.4 plus 17.9 gives you 50.3. And that is all there is to it. And just like any other equation, okay, you can check your answer. So plug 50.3 back in. 50.3 minus 17.9, well, that's equal to 32.4. Okay. Number 2, same thing here. We have 14.7 is equal to 15.3 plus n. Some of us, if we need to, we can flip things around. So we can flip it around the equal sign. We can also flip around this addition here, meaning we could make it n plus 15.3 is equal to 14.7 if we wanted to. Some of us might be able to see from here, well, we have 15.3 plus n. Well, we want n by itself, okay? So once again, if you need to draw your little line there, which I'm not good at drawing a line on this thing, but draw your line there. Well, we want to get 15.3 away from the n. Well, since we're adding these together, all we really need to do is subtract 15.3 to get rid of it, to make this 0 plus n, okay? Same thing here. If we subtract 15.3 from this side, we need to subtract 15.3 from the other side. And once again, the whole point is we want to get rid of that so that the n is over here by itself. And then it's simply just some arithmetic here by doing 14.7 minus 15.3. and that will give you negative 0.6. Okay, so as you can see, pretty straightforward. And at any time, if you want to go ahead and try your hand at the rest of these, so numbers 3 through 12 here on the first set of questions, you can always pause the video, go and try these, and then continue watching just to make sure that you're doing these correctly, because once again, the steps are exactly the same as the equations we did before. Now, number 3, this case, we have negative 4.5 times p, so that means that that's multiplication right there, equals negative 60.3. Well, since this is multiplication, that means we need to divide, and we'll need to divide by what we're multiplying p by, in this case, the negative 4.5, because once again, we want to get rid of the negative 4.5, but if we divide by negative 4.5 on the left, we have to divide by negative 4.5 on the right. Okay. And once again, I'm going to actually stop doing it at this point. But like I said, if you need to do this where the equal sign is, draw your line down through here. Okay. Just so you can make sure you're doing the same thing to both sides of the equation. But in this case, the whole point here is we want these to go away. So we have P is equal to negative over negative is a positive 60.3 over 4.5. I'll be honest, I can't do that in my head. So in this case, I would have to use a calculator. 60.3 divided by 4.5, or if you wanted to include the negatives in on that. But we already know the answer should be positive, okay? But when we do that calculation, we get 13.4. Okay, and everybody does need to get in the habit of writing the steps out. In this case, there's only one step really, so this like plus 17.9 minus 15.3 divided by negative 4.5. In this case, negative 8.5 plus k is equal to negative 27.8. And once again, the whole goal is we want this k by itself. So since we have a negative 8.5 here, we can simply add 8.5 to make this 0. So we have 0 plus k, which just gives us on this side the k. But once again, if we add 8.5 to this side, we got to add 8.5 to the right. And once again, that's a little tougher considering we also have a negative decimal here. But when we add this together, just a little arithmetic, we get negative 19.3. Okay. And like I said, everybody needs to kind of get in the habit of drawing out and writing out your step, whatever your step is, because when we go on to two-step equations, multi-step equations, equations with variables on both sides, it is going to be necessary that you write out the steps, because we're going to be doing so many steps with some of these equations that if you don't keep track of what you've already done, you run the risk of maybe doing it again, or accidentally typing in or using the wrong number in your calculation. Okay. But with that being said, once again, anytime you can pause the video and go through and work the rest of these examples out, and then kind of come back and check your work with the answers that I give here. Numbers 5 through 8 here. So number 5, we have 16 is equal to y divided by 0.3. Well, y is my variable. I'm dividing it by 0.3. So that means I need to multiply by 0.3. But if I do it to the right-hand side, I've also got to do this to the left-hand side. And once again, this is something I don't expect you to do in your head, okay? Because the whole point here is the 0.3s will cancel out. So we get y on this side. But what do we get over here? Well, 0.3 times 16. Well, just once again, if you need to use your calculator, you can find that that's 4.8. Okay. So like I'm saying, all we need to do is follow the same steps that we've done before in terms of do the inverse operation. So if you have division, do the inverse, which is multiply. If you have multiplication, as we see in number 6, then you need to divide. In this case, this is multiplying m by 1.6, so we need to divide by 1.6. But once again, if we divide this side by 1.6, we got to divide the other side by 1.6. And that's where if you need to draw the line so you can tell which side's which. But the whole point here is we want those to go away. So we have m is equal to negative over a positive is a negative. And then once again, I'm going to have to use a calculator for this pretty much. We have 9.44 divided by 1.6. That's something I can't do in my head, okay? I guess technically if you really wanted to, you could go off to the side and do some long division with it, okay? But I'm not going to make you do that considering you do have access to a calculator for this class. So just plug this in, and 9.44 divided by 1.6, we do get negative 5.9. Okay, once again, negative over positive is a negative. And then 9.44 divided by 1.6 is 5.9. Number 7. In this case, this one works very similarly to number 2, in that you've got 7.84 is equal to 2.67 plus W. Okay, once again, we want to get the W by itself, so we would need to get rid of this positive 2.67, and the way that we do that is we subtract 2.67. But if we do it to this side of the equation, to the right side, we've got to do it to the left. Once again, the whole point here is those will go away, so we have W. And then this one might be a little bit easier, 7.84 minus 2.67. That would be 5.17. So that one may be a little bit easier for you to do in your head, especially maybe if you think about it in terms of money, like $7.84 minus $2.67, okay, if you want to think of it in terms of that. And that's something I do want to point out with these equations is this is more likely what you would see in terms of real-world equations, meaning not everything in the real world actually works out very nicely, especially when it comes to money, because there's at least 2 decimal places you got to deal with because of how much change is there, okay? But that goes for other things too, like carpentry, measuring stuff, building a house, welding, any type of math-intensive occupation that you have. A lot of times the numbers don't come out to be nice and neat, even numbers, okay? But number 8, I'm going to go ahead and tell you, works very similar to number 5. We have C divided by negative 8.4 is equal to 6.2. Well, that means we need to multiply both sides by negative 8.4. Okay? Because once again, the opposite of dividing by negative 8.4 is multiplying times negative 8.4. So we get C is equal to positive times a negative. We know it's going to be negative. Once again, this is kind of a tricky one. So 6.2 times 8.4. Once again, it's a hard one to do in your head, but I'll go ahead and tell you that'll be 52.08. So once again, since 1 is negative, it's going to be a negative 52.08. And kind of lost on all this is, once again, if you're unsure if you got the right answer or not, plug it back in. So take this 4.8 and divide it by 0.3 and see if you don't get 16. Take the negative 5.9 and multiply it times 1.6 and see if you don't get negative 9.44, okay? So once again, you can always take your answer and plug it back into your equation just to see if you did it correctly. And then numbers 9 through 12, we'll go through these pretty quickly. Negative 8.01 is equal to P minus 4.49. That means we need to add 4.49. But if we do it to this side, we need to do it to the other side. So in this case, we get P because we want the 4.49s to go away. And then over here, just basic arithmetic addition here, but with decimals. So like I said, if you need to double check yourself and plug this into a calculator, but you should get negative 3.52. Number 10, 0.26 times n is equal to 1.95, so that means we need to divide by 0.26. But once again, if we do it to one side, we got to do it to the other, because we want those to go away. And then over here, 1.95 divided by 0.26. It's, again, another one I wouldn't be able to do in my head, but if you do that calculation, it is 7.5. And the last two here for the first set, we have negative 0.75 is equal to r divided by 25.2. So then that means we need to multiply by 25.2 on both sides. I am going to use parentheses here just so I don't get it mixed up with the negative. If you got a negative number, if you're going to do an operation to it, I just always strongly suggest maybe putting in parentheses. You can even do it up here if you needed to. Okay, once again, you got a negative number, so you don't get it mixed up with, maybe thinking you have to subtract here or anything. But anyways, this will be 25.2 times negative 0.75. Well, positive times a negative will be a negative. And we already know this is going to be equal to r, because once again, the whole point here is we just want to get rid of the 25.2. But when we do the calculation over here, once again, that's a tricky one. It'll be negative 18.9. And the last one of the first ones here, this one, number 12, works just exactly the same as number 4, okay? Except for the numbers just change a little bit. We have negative 19.4 plus x is equal to negative 32.1. Once again, the whole goal is we want x by itself over here. So we got to do something so we get x by itself. Well, the thing we can do is we need to get rid of this negative 19.4, but we're adding it to x. So that means we need to make this 0, meaning we need to add 19.4. Okay, which a little bit of a glitch there. There we go. Because once again, the whole point here, since this is addition, okay, we can make this 0, and that'll give us x by itself. So what makes negative 19.40? Well, let's add a negative 19.4. But if we do the same thing on the right-hand side, once again, a little tougher to do, but definitely possible in your head. But if you need to, double check yourself on a calculator. That would be negative 12.7. Okay, and that's pretty much it for rational equations, except one big thing. Okay, and this is where I will lose a lot of people. And this is with set 2, which has to do with fractions. Okay, so first off, I'm going to actually go through and solve this like you would normally need to solve with fractions, okay? Because that's one of the things in algebra going forward with geometry, any math class that you have after this, it's expected that you know how to deal with fractions, meaning adding fractions, subtracting fractions, multiplying, dividing, simplifying fractions, okay? So everything to do with fractions, you're going to be expected to know how to do. So with that being said, an equation like this, n plus 1/4 is equal to 5/6. Well, the steps are actually the exact same, okay? We see that the variable is n. We're adding 1/4, so that means we need to subtract 1/4. But if we subtract 1/4 on this side, we need to subtract 1/4 on this side, okay? Because once again, we want the 1/4 to go away, so we have n is equal to, and then we run into the issue where we have 5/6 minus 1/4, okay? So I'm going to go over here to the side. Notice I've got more space over here. Just have the one equation here that we're going to do. So we have 5/6 minus 1/4. And once again, technically what people should be able to do by this point is go through and actually do this calculation, okay? Now, some of you are going to want to maybe try to plug this into the calculator. Well, let me show you why that can be a little bit difficult. Well, if we go to the calculator and we type in the fraction 1/4, that's no problem because that's just the answer. It's just 0.25. Okay, and that's a very common fraction people know about by this point probably. But 1/4 is equal to 0.25. Where we run into issues is if you try to type in the fraction 5/6. Notice we get the fraction or the decimal 0.83333333333. And even though this calculator doesn't tell you this, those threes actually go on forever, okay? They go on forever and repeat. So this decimal actually doesn't stop. It goes on forever. So when you're trying to do calculations on a calculator with these types of numbers, that can be kind of messy. Okay. So once again, first off, let me work this out what I consider the old-fashioned way. So just working with the fractions, and then I'm going to show you kind of a shortcut way you can work with the calculator there. If Which I know this is true for most people, that if fractions scare you or fractions give you so much trouble that you can't do what I'm doing here, which honestly, though, you should be able to, okay? And I do strongly suggest trying your hand at working every one of these out the same way that I work this out right here. But like I said, if you have trouble with it, double check yourself on a calculator. I'll show you how you can kind of work with these fractions on a calculator, okay? But in this case, 5/6 minus 1/4. Well, first thing you need to know, if we're going to add or subtract any fractions at all, we need to have what we call a common denominator, okay? So what that means is the denominators of our fractions have to be the same. Now, there's a couple ways you can do this. You can simply just multiply these numbers together and say, okay, my common denominator can be 24, okay? Or you can kind of see and think, well, what's my least common denominator? Meaning, what's the lowest number that I could use here to that I can get between these two numbers? So I'm going to go that route and say, well, if I multiply 6 times 2, I can get 12. Okay. Well, what do I have to multiply times 4 to get 12? Well, I can do 4 times 3 is 12. But here's the thing we have to remember. If we change the denominators here, okay, then we also have to change the numerators in the same way. So if we multiply 6 times 2, we also have to multiply 5 times 2. And if we multiply 4 times 3, we also have to multiply 1 times 3. So our fractions actually become 5 times 2 is 10 over 12. And then we've got minus 3 times 1, or 1 times 3 is 3 over 12. And now that we have our fractions with the same denominator, now all we got to do to subtract these fractions is subtract the numerators. So 10 minus 3 is 7. And then both of them have a denominator of 12. So my answer has a denominator of 12. So our answer here is actually 7/12. And that's a general rule for math as well, is if your question or your equation or whatever it is you're working on is in terms of fractions, your answer should probably be in terms of fractions as well, okay? But that's where we run into some issues, okay? So if you're using your Desmos calculator, which I will remind you is the same calculator you'll have to use on the SOL, so this is why I'm showing you specifically on the Desmos calculator, okay? If you wanted to do 5/6 minus 1/4, you can plug it in just like that is, like I just did right there. So click the things. You actually have this little fraction button here too that helps you with fractions. So if you have trouble knowing that division means gives you the fraction bar, just literally type it in like this. Like do the fraction bar and do 5, click down and do 6. Then make sure you click out so that when you do your operation, it's between the fractions. So, and then do another fraction. Okay. Now, notice here, the answer is given as a decimal, okay? Now, when you're on the SOL test or you're in a testing environment like this, that's the point with this calculator, is it actually doesn't help you go and change this back into a fraction, okay? So that's the trouble you're going to have, and that's why I strongly suggest working out the fractions like so. But just to make it easier on people, I will also accept, if you give me this answer, I will also accept this answer, okay? But you have to be being very clear with this, is if you give me an answer that's a decimal, that should be a fraction, okay? So this answer right here, then you have to give me the entire decimal, meaning you have to give me the 0.583, And then you have to do either one of two things here. Since the 3 goes on forever and it repeats, you either need to put a line over the 3, meaning the 3 repeats, or you need to write it as 0.5833, and then maybe one more 3 if you wanted to, but then give me some dots here, dot, 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 or something to let me know that decimal goes on forever. Okay. Now, in a testing environment, if you had to type in your answer, that's not going to help you, especially if they want a fraction. Okay. But at the same time, in a testing environment, let's say they had answers here of A, B, C, and D. And let's say they said C was the 7/12. A is 3/4. B is 4/3. And D is, let's say, 2. Okay. Well, how would you tell which one of these answers it could be? Well, if you, once again, have trouble, if you do it this way, then the answer is very clear. It would be C, 7/12. But what you could then do is take each one of these and write them out as decimals. Okay. And in doing that, you can see, based on what you did in your calculator, which answer it should be. And that's just 2.0 or 2. Okay. But that's the thing. If you get into a point where you need to know whether the answer you have is correct or not, based on the answers being fractions, we'll just change your fractions into decimals. And then it should be clear what your answer should be there. Okay. But that doesn't substitute for the fact that everybody at this point should be able to subtract 2 fractions or add 2 fractions. Okay. But like I said, whatever you got to do here with the calculator is very handy in that, once again, it will add and subtract fractions for you. Once again, 5, and then make sure you click down, 5/6 minus 1/4, and it gives you the answer, but it does give you the answer as a decimal, which, once again, I'm being kind and I will accept. But like I said, I'm going to be very picky in that if you don't give me the whole decimal, meaning let me know that it goes on forever or not, or show me that something repeats, then I'll take off some points. Okay. Because once again, we got to be very particular about this, because like I said, in general, usually you would want your answer written as a fraction if your question had fractions in it to begin with. So since these are fractions, it's kind of expected of you in a math class or in, just in general, math in general, that your answer should also be a fraction. Okay. But with that being said, let's go on and look at the rest of these, and all of these work exactly the same. Okay. So numbers 14, 15, and 16 here are all going to work the same, except we do end up with a little problem here where we have mixed numbers. Okay. So, but the process is still the same. So we have 11/18 is equal to x minus 3 2/3. Well, that means since we're subtracting 3 2/3, we need to add 3 2/3. Okay. So once again, it's just 11/18 plus 3 2/3. The whole point here is we want these 3 2/3 on the right-hand side to go away. So we have x is equal to, well, whatever this is, we have 11/18 plus 3 2/3. Now, with a mixed number, this is where a lot of people get a little bit messed up, because if you go to the calculator doesn't actually do mixed numbers for you. So 3. So if you try to click the thing there, it doesn't give you anything. You do a space, 3 2/3. Okay. So that doesn't give you anything either. Okay. So what you're going to have to remember and know how to do is, well, a mixed number is just the number 3 plus 2/3. Okay. So if you want to write a mixed number out, that is the mixed number. But once again, look at that nasty number there. It's a never-ending decimal, and actually it has a 7 at the end, but that just tells you that 6 goes on forever and it rounded up. Okay, so it rounded up at the very end. But it should be known 2/3 is the decimal 0.666666666 on forever. Okay. But with that being said, like I said, it's going to be hard to do it. So once again, technically the way we would do this is 11/18 plus, well, 3 2/3. Well, that's going to be 9/3 plus 2/3. So technically you're adding 3 different fractions here if you write it like this. Once again, the 3 is the 9/3. The 2/3 is just the 2/3 there. But then we run into the problem. We can't add all these together because we don't have common denominators. But we can see this one's actually a little easier, that the common denominator could be 18. But that means we need to multiply this times 6, this times 6. But if we multiply that times 6, the numerators also have to be multiplied times 6. So we have 54 over 18 plus 12 over 18. And now when we have all these together, we just add 11 plus 54 plus 12, okay, and that gives us 77 over 18. And that's actually our answer, okay? Once again, that's an improper fraction, okay, but that can be our answer. But like I said, if we have problems with that, then we get to this point, then we could just, like I said, I'm fine with you going over to the calculator. You know you need, so let me erase all this. We need 11/18 plus 3 plus 2/3. And that's actually our answer right here. So in this case, it's 4.27 repeating. Okay, so like I said, you can give me the answer in one of two ways. You can do 4.27 with a line over it, or 4.277 and then ... Okay, so either one of those would work. But once again, if you run into this, you could double check yourself and say, well, especially if it's a multiple choice question, well, that one of the answers is 77/18. Well, make sure 77 divided by 18 is the same number, okay? So that tells you what the answer is as a fraction. But like I said, this calculator doesn't change decimals into fractions for you. So that's, like I said, the best way to do these types of questions is the old-fashioned way here, okay? Number 15, same kind of thing here. We have negative 1/8 plus m is equal to negative 7/24. Well, just like I believe it was number 12, we have a negative plus the variable is equal to a number. Well, it's the same thing here. Negative 1/8 plus m. Well, that means we need to add 1/8. But if we do it to one side, we got to do it to the other. So we get, once again, then the 1/8's canceling out. So we have m is equal to negative 7/24 plus 1/8. All right, once again, we got a negative fraction here, so we got to make a choice here, and I always like to put my negatives with my numerator, so I make it negative 7/24 plus 1/8. The same kind of thing here. If we're doing it the old-fashioned way, quote unquote, is that we need to change this 8. We can change it to a 24 pretty easily by multiplying times 3. So what we end up with here is negative 7/24 plus 3/24. And then all we got to do is negative 7 plus 3. That's negative 4/24. But here we run into a little problem. We can actually simplify that, but we have a negative over positive, so it's going to be a negative. 4 goes into 4 one time. 4 goes into 24 6 times. So it should be negative 1/6. Okay. But once again, we run into this issue where we have some trouble dealing with fractions. But once again, the calculator can kind of come to our rescue here. So negative 7/24. That's the decimal there, plus 1/8. And you could see you get the decimal negative 0.1666666, and it actually goes on forever and repeats. Okay, so once again, two different ways you can answer this question with a decimal are negative 0.16 repeating or negative 0.166 and then do some dots. Okay. So again, if you want full credit for these, in terms of if you give me the decimal answer, you have to indicate to me somehow that the decimal goes on forever. If you just write negative 0.16 or negative 0.167, or if you write what's exactly on the calculator, negative 0.166666667, okay, then once again, that's not really telling me you know what's going on with the decimal. But like I said, just to double check and show you that this is the right answer, let's do negative 1/6, okay, just to make sure it matches up with this. So negative 1/6, and that's the same decimal, okay. So, with that being said here, let's go on to number 16 and look at this one. So once again, we have two mixed numbers here, but it's the same thing. Just think of this as a number. So we have a plus 8.5 equals 5 1/3. Well, that means we need to subtract 8.5. Once again, the whole point here is those will go away to give us a. Well, now we have the problem. What's 5 1/3 minus 8.5? Well, this one's going to be a little tricky, okay, because since we have subtraction here, we're subtracting this, which luckily this right here is a nice decimal. So if we absolutely had to, we could turn that into a decimal, okay? But in this case, technically what we would want to do is we would want to do 5, so that's 15 thirds plus 1/3. But then we would have to subtract 16 eighths, or 16 halves, sorry. That's where the 8 comes from. And this is the tricky part by doing this by hand. We wouldn't add 1/2 here because this whole thing is subtracting. So we would want to subtract an extra 1/2. Like I said, that's the tricky part to doing this by hand. But once again, you run into, we need all of these to have the same denominator, which in this case, the lowest one would be 6. Okay, so we have to multiply this times 2, this times 2, this times 3, this times 3. But if we do that, then that has to be times 3, that times 3, that times 2, that times 2. So we get 30 over 6 plus 2 over 6 minus 48 over 6 minus 3 over 6. And then we just add and subtract all these numbers together. So 30 plus 2 is 32 minus 48. Well, once again, that's a little tricky, but 32 minus 48 would be negative 16. And then negative 16 minus 3 would be negative 19. So it would be negative 19, and all those are over 6, so it would be negative 19 over 6. And I'm fine with improper fractions for answers here, okay? You could technically break this down into a mixed number, which would be negative 3 and 1/6, okay, if you know how to break it down as a mixed number. But like I said, you don't have to do that, because if you go over here to the calculator, let's clear all this out, clear all. Once again, what do we have? Well, we have 5 plus 1/3. Okay, once again, this is because we're dealing with a mixed number here, minus 8. But then, like I said, here's the tricky part is if we're minusing the 8, we also have to minus the 1/2, because the 1/2 is with the 8. Okay, so it's 8.5. So if we subtract the 8, we got to subtract the 1/2. So our answer should be negative 3.166666666 on forever. Okay. Whereas, once again, let me go ahead and hit enter. You can give me that answer. A is equal to negative 3.16 repeating, okay, or A is equal to negative 3.166 dot, 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 dot. Okay. So once again, either one of those answers using the calculator, but you gotta, like I said, full credit, you gotta give me that the decimal goes on forever, something here with the repeating or the dot, dot, dot. Okay. But like I said, just to double check it here, negative 19.6 is what we got. Okay. Well, just type it in, negative 19 divided by 6. And you can see those answers actually match up. Okay. So with that being said, those are all the examples of how to deal with fractions in terms of addition and subtraction. Once again, they work exactly the same way. Now we go to number 17 through 24. And these actually go pretty quickly, especially if you have a calculator, because if you multiply or divide by a fraction, it's actually a very simple process in order to figure out what the answer is in this case. So to divide by a fraction, multiply by its reciprocal. Okay, so this should be something you should have heard of before if you don't remember what we're talking about here. So in this case, when we say we need to divide by a fraction, as we'll see in number 17 here, and I use this on purpose, is if we have the fraction 2/3, well, let's say I wanted to divide by 2/3, well, then I would multiply by its reciprocal, which its reciprocal is nothing more than the fraction flipped around. So 2/3 becomes 3/2. Okay, so what do I mean by that? Well, number 17, what are we doing? We're multiplying 2/3 times x, and that's equal to 48. Well, we're multiplying times 2/3. Well, that means we would need to divide by 2/3. But instead of dividing by a fraction, because that can get pretty messy, even though, it's, again, your calculator can handle it. Okay, so you're going to divide. So let's say you needed to divide, in this case, 48 divided by 2/3, just to show you, 48 divided by 2/3. Well, there you go. The calculator can handle that. So it looks kind of messy here because it looks like you just got this giant big fraction, okay, where you just got a numerator and the denominator is a fraction, which has a numerator and denominator. And like I said, it gets kind of messy, but that is the answer right here. It is 72. But like I said, we can do that a little easier by, instead of dividing by 2/3, by multiplying by 3/2. Meaning if we do it to one side, we got to do it to the other. And the whole point here is 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1x. So we get the x by itself over here. And then now all we got to do is do 48 times 3/2, which, once again, old-fashioned way, we would do 48 times 3. Okay, well, that would give you, let's see, 120 plus 24, so 144 over 1 times 2 is 2, and then technically 144 divided by 2 is 72. But like I said, if you have the calculator, it makes it that much easier because you could literally just do 48 times 3/2, which is the same thing as taking 48 and dividing it by 2/3. Okay. So once again, your calculator can help you out here, and it makes it easy to calculate with fractions in terms of actually writing them out. But do be aware and do be careful when you get your answers. Your answers, the calculator won't turn those back into fractions for you. So like I said with the addition and subtraction before, okay? But with that being said, that's pretty much it with this one, and these can go a lot quicker. So in this case, 7 is equal to negative 1/3 times w. Well, instead of multiplying, instead of dividing, so we're multiplying by negative 1/3. That means we need to multiply by negative 3 over 1. What's the same thing here? Multiply times negative 3 over 1. So negative 3 times 7 is negative 21. Over 1 times 1 is 1 is equal to, the whole point here is these will go away because we get negative times a negative is a positive, 3 over 3, which is 1w. So in this case, we get w is equal to negative 21. Okay. But like I said, the calculator can help us here because, once again, technically what we'd want to do is we would be dividing 7 by negative 1/3? Well, if you absolutely had to, you could take 7 and divide it by negative 1/3. But that looks pretty nasty in there. But like I said, you can kind of, if you need to, you can use parentheses to kind of show what you're going to do in here. All right. But notice we get the answer as negative 21. Okay. So same as what we did here by actually just multiplying out by the reciprocal. Okay, and that's how all of these work. So number 17 through 24 here, they all work the same by just multiplying by the reciprocal. Number 19, 60 is equal to negative 4/5 k. Well, we would have to, this is multiplying times negative 4/5, so we don't need to divide by negative 4/5. But that just means we need to multiply by negative 5/4. Multiply by negative 5/4. And this one's a little trickier, but we do know one thing is the whole point is these will go away, leaving us with k. Because like I said, that's the whole point. If we multiply a number times its reciprocal, they essentially cancel each other out and give us 1. So 1 times k is 1k. Once again, here we can go through and do it this way. Negative times a positive, we know it's going to be a negative. 5 times 60 is 300 over 4. And if we got to do one more calculation there, 300 divided by 4, once again, you could plug that into the calculator over here, or we could just look at it this way. We can go through and simplify. Well, we know we can divide both of these by 2, and then we can divide both of these by 2 again. So that's actually negative 75. Okay. But it's the same kind of thing. If you go back to your calculator, let's clear all this out and just do 60 times, okay, in this case, I want to use parentheses because I got a negative 5/4. See that that's negative 75. Okay, you could have got the same thing as if you did 60 divided by, okay, in this case, I'm going to use parentheses again, negative 4/5. Just make sure that the parentheses are same. So same thing, negative 75. Okay. So once again, the steps are all the same. It's just we're kind of giving you a hint to make it easier to do by hand is instead of dividing by a fraction, you can multiply by the reciprocal. So once again, here, multiplying times 1/4. So instead of dividing by 1/4, we would just multiply times 4 over 1. Multiply times 4 over 1. So once again, the whole point here is 4 times 1 is 4. 1 times 4 is 4. 4 over 4 is 1p. So once again, you can kind of think of those as crossing each other out there. And then we have a negative times a positive, negative. 9 over 4, or 9 times 4 is 36. Over 1 times 1 is 1. So our answer is negative 36. Same kind of thing here. If you look at the calculator, okay, you would have negative 9 divided by technically 1/4 is negative 36. Same thing, negative 9 times, in this case, 4 over 1 is negative 36. Okay. But then, well, this one's still pretty straightforward. In this case, though, we will get a fraction as an answer because just the way it works out. But in this case, we're doing 2/3 times x. So that means we need to divide by 2/3, but is the same as multiplying by 3 over 2. Okay, so once again, the whole point here, those will go away, leave us with x. Negative times a positive is a negative. 4 times 3 is 12. 9 times 2 is 18. And we can actually simplify that out to make it negative. In this case, 12 divided by 3 is 4. Well, actually, we can go even further and do it by 6. So that was almost a mistake on my part. We can actually divide that by 6, divide 18 by 6, so we get 2 over 3. So the answer here is negative 2/3. But where we might run into some trouble is with our calculator, okay? So if you use your calculator to do this calculation, once again, you can do it. It's just going to look very weird, okay? Negative 4/9. So negative 4/9, okay? All of that's going to be divided by 2/3. But then look what happens with your answer. You get negative 2/3, but you get it in terms of a decimal, okay? And once again, you can double check yourself by saying negative 2/3. Well, that's the same decimal, okay? But I do strongly suggest working these out as fractions and actually just doing the operations and simplifying of fractions, okay? Now, when we get to number 22 here, same kind of thing happens, though. We've got this weird thing where we got a mixed number, okay, and it's equal to 2r. Well, in this case, we need to, since this is times 2r, we need to divide by 2. So divide by 2. So once again, we get r is equal to, and this is where, once again, it gets, this is a tough one, okay? So one of the things we can do is go to our calculator and say, okay, well, we need negative 1, okay? But then once again, since it's a negative, then the 1/3 has to be a negative, minus 1/3. And we get that that's the answer right there, but then we want that divided by 2. And we can see that's the same decimal we got in the same last answer, okay? So, I don't want to do that. There we go. Same decimal we got in the last answer. So we know our answer here should be negative 2/3, okay? But how do we do that? Well, I'm going to go down here and negative 1/3. Well, that's going to be negative 1 plus 1/3. So that's negative 3/3 plus 1/3. So this is actually negative 4/3. That's what this fraction is. So we have negative 4/3, all of that divided by 2. So seems kind of weird, okay? But like I said, this is something you can do in a calculator, but in this case, we've got a fraction divided by something here. Well, technically, once again, instead of dividing by 2, we can multiply times its reciprocal. Okay, so multiply times 1/2. So now that makes it a little easier for us if we're dealing with a fraction, because multiplying fractions is actually really easy. 1/2 times negative 4/3. Well, that's positive times a negative is a negative. 1 times 4 is 4. 2 times 3 is 6. And then we got to go the one step further and simplify this so we can divide that by 2, that by 2. So we get 2/3. So negative 2/3. Like I said, that one was a tricky one, okay, because we ended up with a mixed number over here. But knowing how to deal with mixed numbers, that should be something people can do at this point. And like I said, it makes it a lot harder because your calculators actually don't work with mixed numbers that well. Okay, so you got to know how to deal with the mixed numbers yourself. But like I said, I did this calculation down here to show me that the 1 1/3 is just negative 4/3. Okay. And the last two here, okay, dealing with some mixed numbers again. So just to show you, this 7 4/7, okay, once again, you're multiplying, so technically you'd want to divide by 7 4/7. But once again, it's kind of weird dividing by a mixed number. So I'm going to go down here. 7 4/7 is nothing but 7 plus 4/7. Okay. Well, 7 written with a thing there, that's going to be 49/7 plus 4/7. And all I'm doing here is I'm writing 7. So technically 7 over 1. I'm multiplying that times 7. So this has to be times 7. So that's where I'm getting the 49 over 7 plus 4 over 7. That gives me 53 over 7. That's telling me what this is as a fraction. So I can actually rewrite this as 53 over 7 times v is equal to negative 106. Well, 53 over 7, well, if I were to divide by 53 over 7, that's the same thing as multiplying times 7 over 53. Once again, the whole point here is those will essentially cancel out. 7 times 53 is the same thing as 53 times 7. So we have, in this case, it would be, let me think for a second, 371 over 371, which would be 1V. And then here, once again, we run into a little bit of a problem, but negative times a positive is a negative. 106 times 7, well, once again, that's a little bit of a toughie. That would be 742 over 53. But this is where, once again, a calculator can come and help us, because we could simply just do negative 106 times 7 over 53 and see that it's negative 14. We could also just do, like we just did the calculation, negative 742 divided by 53 is also negative 14. So that just tells us multiple ways that our answer is negative 14. So let me clean up that one a little bit. Negative 14. And then the last one, dealing with a negative mixed number here. Well, once again, negative. So that means both the, if you want to think of it, that both the 2 and 12 have to be negative. So that's why I'm using parentheses here. But in this case, it would be negative. Once again, both of them have to have 12. So if I multiply this times 12, 24 over 12 plus 1 over 12. So then that makes this negative 25 over 12. Okay, and that's telling you what this is. So this is negative 25 over 12 is equal to 3/4 C. And now all we've got to do is multiply both sides by, since once again we're multiplying C times 3/4. Well, to get rid of the 3/4, we multiply times its reciprocal, 4/3. And the whole point here is those will go away, so we have C, but we need to multiply this times 4/3. Okay, so what we get here is negative times a positive, so 4 times 25, that's actually negative. And then on the top, we're going to have 100 over 3 times 12 is 36. And then we can actually simplify that a little bit, because we can divide both top and bottom by 4. So we get negative 25 over 9. And that's actually as far as we can take it without writing it back as a mixed number. And once again, if you write that back as a mixed number, that's negative 2 7/9. Okay, but once again, if you give me this answer, but like I said, that's another tricky one, but this is where, once again, a calculator can come into play. Except for, like I said, dealing with the mixed number, that's going to be the key to this one, is making the mixed number into what we call an improper fraction. Okay. But with that being said, try your best with the homework here. I'll try to be as lenient as I can, because I know how much people, have problems with fractions. But do the best you can. Try to use the little tricks that I showed you here with the calculator. And I do strongly suggest using the Desmos calculator here, because that's the one you're going to have to know how to use on the SOL test. Okay, so definitely know how you can deal with fractions with the Desmos calculator here. Like I said, you can literally just, so like if you wanted to do 1/6 minus 5/12 for whatever reason, then there you go. That's 0.25 or negative 0.25. But like I said, the problem with this is it doesn't translate that back to a fraction for you. So, but everybody at this point should maybe know that's negative 1/4. Okay, 1 over 4. But once again, try the homework there. If you get stuck with mixed numbers or anything like that, I do plan on providing everybody with a little sheet with fractions that you can also work on. It's not anything that's due, but it will help you with simplifying fractions, adding, subtracting, multiplying, dividing fractions. Okay. So all those things that we've done here to solve these equations, the main point of this whole section is the steps are still the same. Meaning, if you're multiplying by a number, you need to divide by that number. If you're adding that number, you need to subtract that number. Okay. So once again, always do the opposite of what you're doing in the equation. So once again, if you're multiplying times 7 and 4/7, then that technically means you need to divide by 7 and 4/7. But once again, when you're dealing with a fraction, I mean, you could go over here and do, okay, 7 and then 4/7. Well, once again, that's a decimal, and even though it doesn't look like it, that's a decimal that repeats. It goes 7, 5, 7, 1, 4, 2, 8, okay, and then 7 or 5, 7, 1, 4, 2, 8. So it actually repeats this part over and over and over again. And if you had a bigger calculator and had more spaces, you could actually see how it repeats. But like I said, then you run into the issue, okay, well, that's that number. What do we need to do with that number? Well, we need to divide 106 by that. So we can go down here and do negative 106 divided by the answer we got there. And then you can see it still gives you the same answer, negative 14. So there are some little tricks you can do with the calculator there. So if you need help with that, or you want to learn how you can do different things on a calculator like that, please let me know, okay? But hopefully by watching the video and watching me do these on the calculator, that'll be enough. And if you practice around with it, hopefully that'll be enough to where you can do these questions on your own. But like I said, as always, if you need any help, have any problems, let me know. And good luck on your homework. And as always, thank you for watching.